Hello, I am Reyer Gerlagh, Professor of Environmental Economics at Tilburg University. I frequently use computer models for my research. After COVID-19 emerged as a pandemic, I read many articles and I thought about the models describing the spread of the virus. I like to share my summary of those models. I'm not an epidemiologist or a virologist. My description has not been tested by fellow scientists and is mainly a summary of my own understanding. Yet I hope my explanations are of help if you want to understand what is going on. This is the first video in a series. In this short presentation, I explain the reproduction factor R, which you often hear about in the media. To understand what the R is important for, I also explain something about the time between infections and the rate at which the virus grows. At the end, I explain why so-called asymptomatic infections are important in understanding the spread of COVID-19 and what the options are for preventing it from spreading further. The disease is a coronavirus emerging in 2019, henceforth its name. It gives severe acute respiratory symptoms and is often called SARS-CoV-2 in the medical literature. I will use the term COVID-19. What is the R of a viral disease? It is the reproduction factor, that is, the number of people infected by a patient who him or herself was infected by the virus sometime before. The reproduction depends on the number of contact moments you have during the time you spread viruses, multiplied by the probability that you infect someone per contact moment. For enthusiasts, I write down that as a formula. That also helps to think about options for reducing the R. You can have fewer contact moments, then you reduce the N. You can also keep your distance and wash your hands regularly to reduce the P. To think about this, it helps to fill in numbers. If you do not take measures and you have 100 contact moments, and with every contact moment you have a 3% chance of infecting someone, then your R is equal to 3. In the literature, we often find about the value of 3 for R for COVID-19. Meaning, if you become infected, in turn, you infect an average of 3 other people. How long is the time between becoming infected and infecting someone else? It goes fast. After you are infected, if you get sick, that happens on average after 5 to 6 days. But people spread the virus before they get sick. The average time between getting the virus and passing it on is only about 4 days. We can now use the R and the time between contamination and transmission, T, together to understand why COVID-19 is growing so fast. If you get the virus, you pass it on to 3 other people after 4 days. After 4 days, they pass it on to 9 other people. Still 4 days later, the virus has reached out to 81 people. It goes on like this, exponentially. In a month's time, the virus has passed 7.5 times to about 4,000 people. That is, very briefly and powerfully, the reason the virus is growing so fast. Another major problem with COVID-19 is that the carrier of the virus can pass it on before he or she gets sick. Some people do not get sick at all, while they do transmit the disease. Other people do get sick, but have already passed on the disease before they realize they are sick. Containment of the virus is very difficult for this reason. Even if you isolate anyone with symptoms, the disease continues to spread. Yet, it's clearly important to isolate yourself if you have symptoms, because this will ensure that you infect fewer people. We don't know exactly how many fewer people though. We've now put all the parts together to consider how we can contain COVID-19. We can stay home if we think we might have COVID-19. This reduces the number of possible infections. I assume that the reduction we can achieve through such rules is about 30%. The A drops from 1 to 0.7. We can reduce the number of people we interact with and the number of times we meet them for example by 70%. The N then drops from 100 to 30. We can keep our distance and wash our hands, which reduces the risk of infection. I assume a decrease of 30% for P, which reduces then from 0.03 to 0.02. If we take all those measures at the same time, we can lower the R from 3 to less than half. This means that the carrier transmits less than one new infection. COVID-19 then diminishes instead of spreading. The formula also reveals how measures work together. The better we try to keep our distance, the better we stay at home with symptoms, the more people we can meet when we have no symptoms. This was the first presentation of a series. Thank you very much for watching. I hope it helps you understand COVID-19 better. As a scientist, I add a disclaimer. I am Professor of Environmental Economics. I am not an epidemiologist. I have read a lot of medical literature about COVID-19, but if you find I made mistakes, please let me know. Thank you.